gang, we have a victim of dryness. This is a J45 from what I believe is 2011. It hasn't been played for a while, and it's spent a good length of time in storage. The owner wants to get it playable, but it's got some strange stuff going on. Oh, there it is. So it's good if you want to play one note. The action on this guitar is a scant 2/64ths on the outside strings, which is less than a millimeter. It'd be like 0.8 millimeters. That's crazy. But I think I understand what might have gone on here. I believe this guitar probably had an under-saddle pickup at some point, which was removed. You put the saddle back in and you end up with this, which is virtually no saddle at all. That's not great. However, there's another condition here, and that is the top on this is flat in a way that no Gibson J45 should ever be. Gibson guitars are made with quite a lot of arch on their soundboards. It's like an 18.5 foot radius, if I remember, where Martin guitars are almost flat. If we see a Gibson soundboard that is concave, like we have here in front of the bridge, I mean, the bridge itself almost looks concave as well. That is a sure sign that we've seen some severe dryness, or that the ends of the X-brace may have come loose. So we're going to look inside this thing quickly just to see what's going on. We're happy to see that the X-brace is still hanging in there. The ends are still firmly attached. Very good. There also appears to be a lot of relief in this neck. Yeah, it's around 19 or 20 thousandths. Now when I rehydrate this guitar, it's possible the neck will swell enough that some of that bow will come out of it, but again, this is very loose. Not a whole lot of tension on this. The relief is now 10 thousandths. We'll see what happens. And that has effectively removed the action. There is none to speak of. The strings are now sitting on top of the frets. Just to get a better sense of what's going on here, when I put a straight edge across the lower bout, you can see that it's actually concave on both sides. There's a small portion near the back of the bridge which has still got a little bit of arch in it, but for the most part it's flat or concave. This is an extremely dry situation. All of the arch in the soundboard has been squeezed out of it as the board contracted, and it's under a lot of stress right now. So there's no sense in trying to set it up as is. I'm going to put it in front of my humidifier for a couple of days to get some moisture back in it. Otherwise, anything like any setup parameters that we force this into are going to go away when it comes back to normal moisture. And this is definitely one that will need in-case humidification going forward. The ambient humidity in the shop tonight is 43%, and it's a balmy 60 degrees Fahrenheit. I have 2 hygrometers, just to keep them in check and make sure that one of them isn't lying. So if that was a Gibson, which by all rights should have cracked but didn't, this is a Taylor which certainly did. It's got cracks galore. This is an early Taylor in terms of production numbers. It has a serial number in the low 4,000s. And it was made in 1986. It helps to know that Taylor, for the first couple of decades, was not a high production shop. They made about 900 guitars in the year that this one was made, which is nothing to sneeze at. But compared to other major brands, no. It's probably like 1/10 of what Yamaha made in that year. If we've talked about Taylor, it's been a long time, so maybe we should touch on some of the history. Bob Taylor, 1972, at the age of 18, begins working in a guitar-making shop owned by a fellow named Sam Radding called American Dream Guitars, which is a wonderfully 1972 guitar shop name. This is in El Cajon, which is in Southern California. A couple years later, Sam decides he wants to get out of the business. He sells it to Bob and a partner named Kurt Listug. Listug wisely allowed Bob to put his name on the guitar headstocks. And Kurt handled the business side of things while Bob handled production. By 1976, they were selling through retailers, but again, not huge numbers. They had a couple of employees. They started getting a following in some circles and realized that they had to ramp up production. They got to that sticking point I've talked about before where the economics simply don't work. You're either a very small guitar company or a very big one. There is no in-between, and it's got to happen as fast as you can make it happen. So in the early 80s, they got a big loan, they bought a whole bunch of equipment, and they started cranking them out in larger numbers. The 1980s, of course, was not the time to be trying to do that, to expand an acoustic guitar making company, because the market was so down. And it really took them 10 years before they got to being big, you know. But in that time, they were continuously innovating. And Bob Taylor, he really focused on process engineering and things like the adoption of CNC equipment. He was a real pioneer in the guitar circles for that. And finishing systems, too. California emissions laws are such that, you know, spraying nitro was pretty much out of the question. So he started getting into things like UV-cured urethanes and such long before other makers did. The fascinating thing is he was very generous with the information and the research. And he forged real friendships with other guitar-making companies that were his direct competition. Like he and Jean Larrivée, good buddies, and they were constantly trading notes. Martin, too, which is fascinating. He had a decent relationship with Chris Martin IV, and it's surmised by certain people that Martin was really pushed into the 21st century in terms of its building methodology by Taylor, you know. That competition was real, and if he hadn't been around, they might have just sort of stagnated out of the picture. But he forced them to innovate. In this case, we have an action which is much more in keeping with what we would expect in a 40-year-old instrument. It's pretty high, and again, there's no saddle here. But the main thing is we want to shore up all of the cracks in the soundboard. I am seeing 1, 2, 3, 4... 5, 6, 7, 8. There's also one back brace, at least, that I can see, which is loose, and it's possible there's something going on with a brace under the top. Taylor was also, of course, instrumental in sort of popularizing or legitimizing the bolt-on neck, and this one has faced some difficulties over the years. I'm going to check and see how solid that is. Okay, so the action on this guy is more than 8/64 on the bass side, 7 on the treble, which is a foul ball in any man's league. And just checking out the relief here, I can tell again that we're probably more than the heaviest leaf in my collection of feeler gauges. And yes, so it's more than 25 thousandths of an inch. Let's see if the truss rod works. So this will be a 1/4 inch. It has been adjusted in the past. Okay, there is some tension on it, and it moves freely. Okay, again, that's maxed out, and we're around 11 thousandths. Let's see how that does. The action now is 7/64 and about 5.5/64. Okay, put a ruler on the surface of the frets, and it falls a few millimeters below the top surface of the bridge here. We would, of course, ideally like to see it slightly above. That should give us plenty of saddle height. So yeah, it is time for a neck reset. It's possible that someone did one on this previously. Of most concern to me, there are 2 cracks running on either side of the fretboard, which are really the widow makers of the acoustic flat top guitar. That can spell doom in a real hurry, especially if they've broken through the rosette and into the sound hole, which is not the case here, which is a good thing. Because that usually means that the entire neck assembly is collapsing inward. There'll be major misalignment and, well, just it's a mess. This is a fairly heavily built design. They've got 2 transverse braces pretty close to the sound hole, and then there's also something like a popsicle stick brace between those and the neck block. So this is fairly supported in this area, and that's probably why this has not collapsed to the point where it would be a serious issue. But we do want to make sure those are glued up. This guitar has an undersaddle pickup in place, which the owner does not want anymore. Let's see if we can get this out. And what are the chances this thing is going to go back down the hole? Probably not. It seems like a very old Fishman style pickup. This thing is literally threaded through the block. Ironically, I'm going to thread it back in there once I've clipped off the wire. But there's like 2 inches of thread. Fun. Because I'm going to be doing a neck reset, I'll loosen the fretboard extension, take the neck off now because it'll make getting access to the cracks a little bit easier. This is put together with an aliphatic type glue, so I'll put the plastic in there while it cools down to prevent the parts from re-adhering. I'll loosen the 2 attachment bolts, a little miniature socket. Nothing fancy about these, very much a hardware store variety bolt. I think it's a 7/16 inch head. And when I take out the lower bolt, I discover to my tremendous satisfaction that the crack was a real crack, and the heel is in 2 parts. So I'll remove the strap button to give myself some room to work. The nice thing is the surfaces are clean, and they key into each other really well. So I'll get some glue in there. Clamping can be tricky on heels with heavily slanted ends. I do have an angled caul for such occasions. Looks like most of these cracks have been open for a while. The wood in there is darkened through exposure to air. It's not like I can really clean them out very much. So I'm just going to put a bunch of fish glue in this case in there. And because this is fairly well hydrated at this point, the cracks are actually pretty tight. So the glue is going to swell things up. I'll use a little bit of lateral clamping pressure and some cauls on top, try and keep things flat and level. The suction cup just helps push the glue into the crack. Protein-based glues, hide glue and fish glue, have a lovely quality to them where they contract as they dry, pulling the sides of the crack even tighter together. Okay, clean some of that off. This kind of clamping doesn't take a tremendous amount of pressure, just enough to keep things level. And yeah, there's a whole lot to do. Here's a fun one. There's a previously repaired crack running up here in the back where either the side or the back itself took a pretty serious hit. And though that has been glued up, the back itself is loose from the lining in this area. You can see that the hit was substantial enough to break one of the sections of kerfed lining away. I'll clean the area with some naphtha. Try not to drag any dirt into the space between the back and the lining. We'll use a flexible little probe of spring steel to get the glue in there. We'll button that up with some spool clamps. There was a split in an X-brace near their junction point, so I glued that too. Several days in the moist jungles of Virunga have left this less concave and slightly more than flat. And I feel more confident in setting it up. This saddle is exceptionally loose in its slot. And it has what appears to be a shim Not full length, only a portion of it. This is a piece of plastic of some description, rubbery plastic. I think it deserves a brand new saddle. So at this point, without any context and no string tension on it, this to me would present as quite an overset neck. And to be honest, I'm seeing some Gibsons coming out these days which have this kind of geometry to them. I imagine that this top is going to expand a bit more. It might be that we'll have to reduce the action come, June or July. But at this point, it's going to be a tall saddle, no matter what we do. I'm going to take some 220 grit paper on a flat block and sand the surface of the bridge pad, just to clean off any oxidation or grunge or leftover adhesive from previous pickups. Pull out this strap button, which has been ingeniously wrapped with plastic tape and a rubber band to hold it in place. Kind of works, actually. And I'm going to be using a pickup which is like a Chinese version of the K&K. This is a Journey Tech. They're fine. The sensors are a little bit larger than the ones you'll find in K&K. For whatever reason, the K&K pure mini pickups, which I love so dearly, have increased in price by like 60% in the last 2 years. A huge amount, to the point where it used to be sort of my mid-level kind of go-to. Now we're going for some of the Amazon-based stuff, it seems. Journey Tech gives you a rather half-hearted clone of the K&K positioning guide. It'll work. Want a thin, even layer of thick viscosity super glue. See, I've got a piece of rubber glove on my fingertip just to prevent me from getting stuck in there. Okay, and then just hold it in place for about a minute. New saddle blank goes in nicely, snug enough to suspend the guitar. I'll mark out and file the intonation points. In my world, if you tie the strings on, a man comes out of the back room with a hammer and a circular saw. Here comes the fun part. We just polish the devil out of it. Okay, we're all set up. I left it just a little on the lower side because I expect there is still room for this to plumpen slightly. And I sometimes like to think in terms of the responsible setup being one that's playable today and will still be playable in 6 months. And the other thing is, yeah, that saddle height is 1/4 of an inch above the surface of the bridge. To my mind, that's too tall. 3/16, okay. But again, this guitar is 15 years old now. So, yeah, it's tall. We get away with it in a Gibson bridge because it's got the reverse belly design. There's lots of real estate in front of it. It's not probably going to crack off. And also the saddle slot is pretty deep. So there's lots of support there. But yeah, it's a J45. It's a workhorse guitar. Let us put it to work. More cracks. This one's on the back. Here's another tip. If you don't have a suction cup to pump the glue in, this is one from Pablo Requena, who's a classical builder. Surrounds the crack with painter's tape, puts a generous dollop of glue in there, and there's no place for it to go except down in the crack when you rub it in. It's a good trick. And here we have the original Taylor neck attachment. 2 bolts, no tenon, 2 insert nuts. Just about as simple as you could hope for. Here's the thing, and this might cause consternation. I like the sound of Taylors made with this neck. The subsequent one, the NT system, new technology, came about in the late 90s, and that's the design with graduated shims that go in a pocket under the fretboard extension and also between the heel and the neck block, which solves the issue of neck resets entirely. It's fabulously engineered, but for whatever reason, I've never experienced the hair rising on the back of my arms when playing a Taylor made during this century. I can't tell if other aspects of the design changed, and those are the reason, or if it's specifically the neck attachment. It's just something I've noticed, and I've played a lot of them. Other people get along with them just fine, of course. A lot of people like the neck carve. Taylors tend to have a fairly low profile neck for an acoustic guitar. So resetting this is not so different from standard dovetail, except they didn't really figure on future repair needs because the insert nuts are glued flush with the surface, and I have to do sandpaper pulls, of course. I can't tell how much this has been fooled with. This one feels far more proud than this one. When I make a neck like this, I always include a 5/8 inch 16mm diameter dowel rod that goes right down the center of the heel, which keeps things together and gives the inserts some side grain to bite into, so they're pretty secure. The other thing I do is soak the entire surface of the end grain with thin super glue, which will consolidate any little invisible checking or micro splits that might be lying in wait. It looks like they put some around the inserts here. I don't know what this white glue is, this white material is. In a case like this, I think I'm apt to relieve the area on the guitar body itself rather than trying to maybe file these down below the surface or something, or maybe drill them, just because it seems like there's more possibility for disaster. So we'll make what is in effect a very shallow mortise and tenon. This is a 1mm deep channel in the area around the bolt holes. So we'll do the sandpaper pulls, which removes more material at the end of the heel than up near the fretboard. This in effect causes the neck to tip backwards relative to the body, thereby raising the projected height of the saddle and lowering the action. I have one of the bolts loosely in place while I do this. When I've done enough of that, the straight edge now projects to a point that's about a 32nd of an inch above the bridge, which would be about 0.8mm. And this too gets a new saddle. I made a bunch of spruce cleats for some of these unsupported areas. I'll glue those all in with magnets. And the back brace needs to be supported from the outside, so the jack has something to back it up. Much of the world is fretted, and one day we will do the polishing. The saddle has been intonated and the action lowered, and we end up with a saddle exposure of 5/32 of an inch, which is just under 4mm, which is as tall as I ever want them.